Welcome to section 7.4. The derivative formulas, 19 and 20, are the formulas we covered last time. And here's an overview of where we are. We've learned how to take the Laplace transform of a differential equation. Now we can solve for y. And today what we're going to do is work on going backwards. And then in the next section, we'll put it all together and solve some differential equations. So let's work on inverse transforms. We talked about this a little bit the last time. Let's look at this first example here. I want L inverse of 3 over s to the fourth. Well, my starting point is formula number 2, which would tell me that L of t cubed is 6, which is 3 factorial over s to the fourth. Well, I have a 3 over s to the fourth, so that's okay. I can simply divide by a half. So this is equal to 1/2 t cubed. The next one, my starting point is formula number 6. Remember, with sine and cosine, sine does not have the s on top, cosine does. And so this is formula 6. And so I don't want a root 7 on top, so I'm simply going to take 1 over root 7 sine of root 7 t. And that's my inverse transform. Again, I'm reading the table backwards, but I'm having to do a little bit of detective work as I do that. Okay, next one. If you look at your table, all the coefficients of s are 1. And so if you run across something like this, you're going to have to rework it so the coefficient of s is 1. And so what I did here is I wrote this term as 1 over, I pulled out a 3, and I've got s minus 2/3. And all of that was squared. All right, and then I distribute the square. 3 squared is 9. That's where this 9 is coming from. And then I'm left with s minus 2/3 squared. And so what this looks closest to me like is formula number 4 with a equal 2/3. So this is equal to 1/9 t e to the 2/3 t. Okay, now 3 a little bit tougher ones. L inverse of this expression here, CS stands for complete the square. So whenever you complete the square, you want your leading coefficient of the quadratic term to be 1. And so the first thing I did, I left off the L inverse. I'm just going to complete the square here. I pulled this 2 out. Okay, and now I'm ready to complete the square. I've got a 3 on top. Well, actually, I'm going to take that 2 down here and put it up top. So I have 3/2. And now I'm going to complete the square on s squared plus 4s plus 5. That's going to be s plus 2 quantity squared. And when I square that out, I'll get s squared plus 4s plus 1. But I want plus 5, so I'm going to add 1 as my correction factor. So now I'm ready to put the L inverse on. L inverse of that expression. This is formula number 8 with a equal -2. And b equal to 1, and the 3/2 is a constant, so this is 3/2 e to the -2t sine t. Now I'm going through these pretty fast, so it might take you a while in the beginning to sort this out, but eventually you'll get it. Okay, next one, this is the most popular type. You're going to complete the square and use 2 formulas, 8 and 9. So 8 and 9 are going to be your friends. So here we go. I want L inverse of s plus 3 over, and complete the square on the denominator, that's going to be s plus 1 quantity squared plus, if I square that out, I get s squared plus 2s plus 1. I need plus 10, so my correction factor is a plus 9. Okay, now that doesn't look like formula 8 or 9. Whatever's here, I need the same thing to be up top in order to use formula 9. So what I'm going to do is write this as 2 fractions. This is L inverse of s plus 1 over s plus 1 squared plus 9 plus, now I had a plus 3 on top. Here's s plus 1, so I'm missing 2. So add 2 more, and then same denominator. The first one, this is number 9, and this one is number 8. And they both have a equal to -1 and b equal to 3. Now, there's nothing I have to do to the first fraction, but for the second fraction, I've got a 2 on top. I'd really like a 3 on top. And so I did my scratch work over here. I simply pulled out the 2, put a 3 on top, and since there wasn't a 3 on top, I divided by 3. So now I'm good to go. This is equal to e to the negative t cos 3t plus 2/3 e to the negative t sine 3t. So you're going to have to do that type of computation again and again, so you might want to come back to this video if you need to. All right, now we're going to talk about partial fractions. And it's been a while, I agree, so we're going to do 3 types. I'm going to talk about 2 distinct linear factors. I'm going to talk about a linear and an irreducible quadratic, and then I'm going to talk about a repeat linear. All right, so here we go. I've left the L inverse off, and first I'm just going to do the partial fractions on this expression. And notice the reason I'm doing this is because the way it stands, this doesn't seem to match up to anything in my table. All right, so the first thing you do when you do partial fractions, you make your decomposition, and then you clear fractions. So multiply both sides by the denominator over here, and that gives us 1 equals a times s plus 3 plus bs. All right, and then we pick convenient values of s. If s is 0, then I get 1 equals 3a. So now I know that a is a third. If s is negative 3, I get 1 equals negative 3b. So b is negative a third. All right, and so now I'm going to put my L inverse back on. I want L inverse of a over s. A is a third. Leave the whole 1/3 on top. I know it's a complex fraction, but it's easier that way. And then minus a third over s plus 3. Now this is formulas 1 and 3. L inverse of 1 over s is just 1, so we have 1 times a third, which is a third, and then minus 1/3 e to the negative 3t. Piece of cake. All right, 2 more. In the interest of time, I'm going to make these go pretty quickly. You can always pause the video, but I strongly suggest you pause the video first and try these on your own. So this first one factors as a linear and an irreducible quadratic. And so first thing I want to do is clear fractions. 1 equals a times s squared plus 4 plus bs plus c times s. All right, now I'm going to pick convenient values of s. I'm going to need 3 of them. I'm going to start with s equals 0. That gives me 1 equals 4a. So now I know that a is a fourth. Okay, now maybe s equal 1. Then I get 1 equals 5/4, because remember, a is a fourth, plus b plus c. Well, that tells me that b plus c is negative a quarter. Just put that on the back burner for now. Now pick another small value of s. Doesn't matter what it is. I'm going to go with negative 1. And then I get 1 equals, again, 5/4. But now, when I put negative 1 in for s, I get plus b minus c. And so that tells me that b minus c is also negative 1/4. Okay, 2 equations, 2 unknowns. This gives me, I'm just going to add them together. 2b is negative 1/2. So b is negative 1/4. Plug that back into either of these equations to see that c is 0. So now I'm going to put my L inverse back on. I want a over s. A is a quarter, so 1/4 over s, and then plus, I've got b was negative a quarter, so negative 1/4 s, c was 0, over s squared plus 4. Okay, so this is formulas 1 and 7. So this is simply 1/4 minus 1/4, this is a cosine one, cos of 2t. And that's it. Okay, next one. This is a repeat linear. And so I've done the partial fraction decomposition. Again, you can look on the last page. And so I want to clear fractions. 2 minus s is a times s plus 1 plus b. All right, if I let s equal negative 1, then I get 3 is b. And if I let s equal 0, I get 2 equals a plus b, but b is 3. So now I know a is negative 1. Okay, so now I'm ready to put my L inverse back on. I want negative 1 over s plus 1 plus 3 over s plus 1 quantity squared. Okay, this is going to be formulas 3 and formulas 4 respectively. And so this is negative e to the negative t equals negative e to the negative t plus, this one's going to give me 3t e to the negative t. Okay, last one. I just would like to comment that I expect you to be able to do all the partial fraction problems in your homework and the ones we've done today by hand. However, that doesn't mean you have to necessarily do them all by hand. Let's say you're doing your homework and you're fairly confident in your partial fraction capabilities. You can go ahead and use some outside help like a Symbolab calculator to do partial fractions for you. And so that's what I've done in this example here. Now this is a repeat linear plus a distinct linear, so it might take me a few minutes to do the partial fractions, so I'm just going to get some help. And so this is a homework problem you have, and I just want to show you, the wording is a little strange, so I want to go through it with you. We want to find L inverse of big F given this expression here. So the first thing I do is I factor out a big F. That's what I did here. And I'm left with s minus 4. And on the other side, I have s plus 3. And then I recognize that s squared plus 8s plus 16 is a perfect square. That's s plus 4 quantity squared. All right. Now I'm going to divide both sides of this expression by s plus 4, so have big F isolated. All right. Then this is what I put into Symbolab to get the partial fraction decomposition. Now, when you do that, Symbolab, they won't use complex fractions. So instead of negative 7 over 64 over, so this one, negative 7 over 64 over s plus 4, they're going to write it like this. Now, for us, it's more helpful to keep that negative 7 over 64 on top. And so that's what I've done here. I'm going to take L inverse. Let me erase some of this mess. I'm going to take L inverse of both sides of this equation. And as I do that, I'm going to write down the partial fraction decomposition on the right-hand side. And so now I'm good to go. Remember, I'm solving for L inverse of F. So L inverse of big F is, you can just read right off our table. This first one is going to be negative 7 over 64 e to the negative 4t. The next one, it's going to be a 1/8 t e to the negative 4t. And then the last one, plus 7 over 64 e to the 4t. And that's my answer. And so this was number 3. This was number 3, and this was indeed number 4. Okay, and that is the end of this section.